Today we are taking a look at something called function notation. Function notation, that'll be the title of today's lesson. And we will start by defining function notation. Function notation is a way of writing functions that makes it easy to distinguish between them. Makes it easy to tell the difference on which function is which. So it's another way of writing functions. And we use it because it makes it easier to distinguish between the functions. And we'll talk about what that means here in a minute. So this right here, f with an x in parentheses next to it, or it could be a g, or it could be an h. Those are the most common ones, but really the function could be defined as any letter, usually f, g, or h. F of x is the same thing as y. It means the same thing as y, it's just another way of writing y. And I just read this part out loud. Again, that is read f of x. F is the function, x is telling us what the variable is. F of x. So most often, instead of this f of x notation, we've been using y, and we'll continue to use y a lot. But if you have more than one function, and you say y equals 3x minus 1, that's one of my functions I'm going to be working with. And then I say y is equal to maybe x squared, and that's another function that I'm working with. Well, we called both these functions the same thing. We called them both y, even though they're different things. So if I want to plug 2 in, and I want to plug 2 into the bottom thing, it's hard to show like which one we should be plugging 2 in for x. Whereas if I called these, this one is f of x, and this one is g of x, now I can very easily show that I want to plug 2 in for my x into the g function. So notice the x is 2, and it's saying to plug it into the g of x equation. Whereas if I wanted to plug in 2 into the top equation, we would write that as f of 2. F of 2 means go to the f of x equation and plug 2 in for the x. We replace the x with a 2. So it makes it easier to distinguish between these different functions if I call one of them f and one of them g, and just instead of just saying y equals y equals. So our first example says that we are given f of x is equal to 3x minus 5 and g of x is equal to 4x plus 3. We are asked to evaluate each of the following. Evaluate each of the following. So starting with number 1 here. Number 1, this is read f of 2. We need to know what is f of 2. Well, notice this says f of x is equal to 3x minus 5. So f of 2 means go to the f of x equation. So we're using this one. And we are replacing the x with a 2. Instead of x, I have 2. So f of 2 would be equal to, instead of x, I'm putting in 2. So I rewrite this function here, but I'm replacing the x with a 2. 3 times 2 is 6. 6 minus 5 is 1. F of 2 is equal to 1. That means for the f of x equation, when x is 2, y is 1. Number 2 asks us to evaluate g of negative 5. G of negative 5, so we're using the g of x equation this time. And my x value is negative 5. So I'm going to the g of x function. I'm replacing the x with a negative 5. 4 times x plus 3, so I'm doing 4 times negative 5 plus 3. Order of operations, we multiply before we add. 4 times negative 5 is negative 20. Plus 3 gives us negative 17. Number 3 says g of 0. First, decide which function we're going to use. We're using the g of x function. And I'm putting 0 in for the x. Instead of x, I'm putting in 0. For x plus 3, so I'm doing 4 times 0 plus 3. 4 times 0 is 0. Plus 3 gives me 3. Number 4, f of negative 1. F of negative 1. So we are going to f of x. And instead of x, I'm putting in negative 1. Negative 1 in for the x in the f of x equation. Notice f of x is 3x minus 5. So f of negative 1, it's the same thing, but negative 1 instead of x. Negative 1 instead of x. Multiply and subtract. Number 5 says g of 2. G of 2. G of x equation. 2 in for the x. Multiply and add. And hopefully we're starting to get the hang of this. The last one asks us to evaluate f of 10. F of 10. F of 10, so we're going to the f of x equation, and we're replacing the x with a 10. Multiply and subtract, giving us 25. The next set of problems, very similar, gives us two functions. Notice it calls it q of x and r of x instead of f and g. The equations are a little bit different, but we're going to work through it the same way. What I want you to do right now is I want you to pause the video and everybody on your own try numbers 7 and 8. Once you think you have it, and everybody has it, go ahead and start the video and then we'll show you how to do it. Number 7 asks for q of negative 3. So we're going to q of x and we're replacing the x with a negative 3. 7 minus 3 times negative 3. Looks like we have this subtraction and then multiplication. Remember order of operations. Parentheses, exponents, multiply and divide, add and subtract. We multiply before we subtract. So I need to do negative 3 times negative 3. Negative times negative is positive 9. Bring my 7 down. 7 plus 9 is 16. R of 2. Here's r of x. I'm replacing the x with 2. I get negative 1. Number 9 is a little bit different. We'll do number 9 together. It asks us to evaluate q of 2c. Q of 2c. Well, if it said q of 2, we would go to q of x and we would replace the x with 2. Q of 2c, we do it the same way. It's just instead of replacing x with a number, I'm replacing x with an expression, in this case 2c. So it would look like this. I would have 7 minus 3 times x. But instead of x, I'm putting in 2c for the x. Multiply Negative 3 times 2c, that's negative 6c. 7 and minus 6c, this one has a c in it, this one does not. Those are not like terms. I can't combine them. There's nothing else I can do. Number 10, r of 3d minus 2. R of 3d minus 2. So the r tells us which function we're using. We're using the r of x equation. This is the equation I'm going to use. Instead of x, I'm putting in 3d minus 2. So I've got negative 2x plus 3, negative 2x plus 3, but instead of x, I'm putting in 3d minus 2. And we need to simplify. We can distribute this negative 2. Negative 2 times 3d. Negative 2 times negative 2 is plus 4. Don't forget about this plus 3. I'm just going to bring it down. And now we've got a couple like terms here that I can combine. Negative 6d plus 7. Last type of problem we have here, numbers 11 through 15. Looks similar. Number 11, notice it asks g of negative 2 and 12 f of 3 and g of 3 and so on. What's different is instead of giving us an equation for f of x and an equation for g of x, they're giving us a graph of f of x and g of x. So notice y equals f of x is the blue graph, and y equals g of x is the red graph. If you're taking good notes, you should sketch this in your notebook here. Negative 1, 2, 3, 4. This point right here is at negative 4, 2. Negative 4, 2. Negative 2, 2. 0, 0. 1, 2, 3, 4. And 4, negative 4. So negative 4, 2, 2, 2, 0, 0, 4, negative 4. Label that as g of x. Those points get connected with straight lines. And then if we're looking at the f of x equation, we've got negative 4, negative 2, 0, 2, 2, 2, and 4, 4. And again, we're just connecting everything with straight lines and label that one as f of x. These problems are way easier than they might look. G of negative 2. G is telling us which function to use. I want to use the g of x function. That is the one in red. It's saying the x value is negative 2. And remember, way back on slide 1, we said f of x or g of x is the same thing as a y. So it's giving us, this is the function, g of x. It tells us to use that one. This is our x value. It wants to know what is the y value. So when x is negative 2, g of x has a y value of positive 2. F of 3. F of 3. It's f, so we want the f of x equation, or the f of x graph, I guess. When x is 3, the f of x equation is 1, 2, 3. Has a y value of 3. G of 3. G of 3. We're still going to x equals 3. X equals 3, but this time we want to know what is g of x. G of x is down, so negative 1 to negative 3. F of negative 2. F of x, that's the blue one. When x is -2, y is 0. F of 0. F of 0. F of x is the blue one. I need my x value to be 0. I want to know what is the y value. When x is 0, the y value of f of x is 2. That's it for today's notes. Reach out to your instructor if you're having questions.